Good afternoon to all. I am Dr. Rashmi Shrivastava, lecturer, Department of Applied Sciences, IIMT College of Polytechnic, Greater Noida. Today, I am discussing about chemical bonding. What is chemical bonding? Chemical bonding is a type of link between the atoms, molecules, or ions to attain the stable electronic configuration of noble gases. Chemical bond. How will you define a chemical bond? Chemical bond means force that holds groups of atoms together and makes them function as a unit. Between the atoms, molecules, or ions, the link is of the nature of electrostatic force of attraction, which binds a group of atoms, molecules, and ions to attain the stable electronic configuration of noble gases. Now, what is bond energy? Bond energy is energy required to break a chemical bond. Today I am discussing about, there are two types of chemical bonds. First is ionic bond. What is ionic bond? Ionic bond is a bonding between the metals and non-metals. Metals means the atoms which are highly electropositive in nature. Electropositive means atoms having more than the electrons in their outermost orbit, which is also known as valence shell. All we know that valence shell having the electrons which are participating in the bond formation. So ionic bond is formed between the two atoms. One is of metal generally and the another is non-metal. The metal atom having one or more electrons extra, which they are capable of donating to the another atom, and thus the metal atom is converted into positive ion, and it is highly electropositive in nature, and it is known as the donor atom. The another atom, which is generally of halogen group, and it have lack of one or two electrons. This type of atom gain one or two electrons from the outermost orbit of the metal atom, and it is known as the acceptor atom. So there are two types of atoms in ionic bonding. One is donor and the another is acceptor. Donor having extra one or two electrons in its outermost valence shell, and acceptor having one or two lack of electrons to attain the electronic configuration of noble gases. The bonding between this metal and non-metal is known as the ionic bonding, and the force of attraction between them is electrostatic in nature. This bonding is very strong because the complete transfer of one or two electrons from the metal atom to the non-metal atom, and this type of exchange takes place between the valence shell of metal atom and non-metal atom. Ionic compounds results when a metal reacts with a non-metal. Metal, which denotes by the M, and non-metal, which denotes by the X. When they combine with each other, the compound formed is called ionic compound, and the nature of bonding is called ionic bonding, and the Force of attraction is electrostatic in nature. The another type of chemical bond is covalent bonding. Covalent bonding is defined as the sharing of one or two electrons between two identical or non-identical atoms. Identical atoms means the same atoms, and when they form covalent bonding, the sharing of one or more electrons between the two atoms. As we can see, hydrogen atom, two hydrogen atoms, they form covalent bonding, and this type of bonding takes place between the identical atoms. The sharing, or we can say the shared pair of electrons, lie exact between the two atoms, and the H2 molecule is formed. A covalent bond results when electrons are shared by nuclei, and when the identical atom participating in covalent bonding, the shared pair of electron lies exactly between the two identical atoms. The another type of covalent bonding takes place between non-identical atoms, just like HCl. Just like HCl, one atom is H, hydrogen atom, and the another atom is Cl, chlorine atom. When the covalent bonding takes place between two unequal or unidentical atoms, then a polar covalent bond results. A polar covalent bond results when electrons are shared by unequally by nuclei. One atom attracts the electrons more than the other atom. When two non-identical atoms participating in covalent bonding, then one atom attracts the electron more than the other atom when their electronegativity difference is greater. Just like if the theoretical approach taken, the probability map would look like if the two electrons in the hydrogen fluoride bond formation, which is a covalent bonding between two non-identical atoms, are shared like this. But a polar covalent bond is formed actual situation when a polar covalent bond takes place between hydrogen and fluorine. The shared pair of electrons shifted towards the fluorine atom due to its high electronegativity. The electronegativity of hydrogen is much less than the fluorine atom. That's why the shared pair of electrons shifted towards the fluorine atom, and the compound become polar in nature. Electronegativity. The electronegativity means the relative ability of an atom in a molecule to attract shared electrons to itself. It means the electron attracting power of the atom is greater than the another atom, then the electron pair is shifted towards the atom having greater electronegativity than the another atom. In periodic table, the electronegativity increases from left to right and from down to up. Increases from left to right across a period and decreases down a group of representative elements. Now concept check If lithium, which is the element of group 1, and fluorine reacts, which has more attraction for an electron, and why? In a bond between fluorine and iodine, which has more attraction for an electron, and why? The answer is fluorine, because fluorine is highly electronegative in nature as compared to the lithium. And in the second concept, when a bond taken place between the fluorine and iodine, the more attraction is the fluorine, because the electronegativity increases towards the fluorine. What is the general trend for electronegativity across rows and down columns on the periodic table? Electronegativity, the polarity of a bond, depends on the difference between the electronegativity values of the atom forming the bond. It means the polarity, how much the compound is polar or medium polar or non-polar, it depends on the electronegative character of the participating atoms, molecules, or ions. If the electronegativity of participating atoms, molecules, or ions is greater, then the compound is more polar. And if the electronegative difference between the participating atoms, molecules, or ion is less, then the compound is non-polar in nature. A covalent bond formed between identical atoms. If the covalent bond is formed between the identical atoms, just like H2, Cl2, N2, then the shared pair of electrons lies exactly between the two identical atoms, and thus the compound is non-polar in nature. But if the compound is HCl, in which the hydrogen having very less electronegative as compared to Cl, chlorine atom having a very much greater electronegative in nature, then the electron pair is shifted towards the chlorine atom and the compound attain a partial positive charge towards the hydrogen atom and a partial much more negative charge towards the chlorine atom, and the compound become polar in nature. Bond polarity and dipole moments. A dipole moment results when a polar molecule has a center for positive charge separate from a center for negative charge. Dipole moment is a concept of polar compounds. When a polar compound, then it having a dipole moment. Dipole moment means just like if a compound is very less electronegative in nature and the another is highly electronegative in nature, then the partial positive and partial negative charge develops at the extreme end of the compound, and thus a dipole moment results when a polar molecule has a center for positive charge separate from a center for negative charge. Just like water molecule. Water molecule is a polar compound in which hydrogen having partial positive charge and oxygen having partial negative charge. The polarity of water affects its property. Permits ionic compounds to dissolve in it. As all we know that water is a universal solvent. When the water is a universal solvent, then it permits ionic compounds to dissolve it due to its polar nature and its high dipole moment. Now, stable electronic configuration and charges on ions. Group 1 metals always having, in periodic table, group 1 metals always having +1 charge. Group 2 metals always having +2 charge. Aluminium in group 3 always having +3 charge. Group 7 non-metals having -1 charge, and group 6 elements always having -2 charge. Atoms in stable compounds usually have a noble gas electronic configuration. Metals lose electrons to reach noble gas electronic configuration because metals having 1 or 2 extra electrons in their valence shell, they are capable of donating it and form the ionic bond. Non-metals gain electrons to reach noble gas configuration because non-metals having lack of 1 or 2 electrons. So metals and non-metals combine with each other by the ionic bond formation. Just like group 1, lithium, sodium, potassium, rubidium, group 2, beryllium, magnesium, calcium, strontium, barium, group 3, aluminium, and group 6 and 7, all having a tendency to gain or lose the electrons and attain the electronic configuration of noble or ideal gases. Chemical compounds are always electrically neutral because chemical compounds having the stable electronic configuration. Ionic bonding and the structure of ionic compounds. Ionic compounds having a crystalline structure because they are packed very closely to each other and form a crystal. In ionic bonding, one is donor and the another is acceptor. The donor is called cations. Cations are always smaller than the parent atom. Why? Because cations donate the electrons from their outermost shell or orbit and they dissolve their orbit and thus their size are much smaller than the parent atom. Anions are always larger than the parent atom because ions are lack of 1 or 2 electrons. That's why they gain the electrons from the cations and having much electrons as compared to the parent atom. Ionic compounds containing polyatomic ions. Polyatomic ions means polyatomic ions means much more than 2 atoms combined with each other and not in the stage of stable configuration. They are having 1 or more charges, then they are known as polyatomic ions. The covalent bonds hold the polyatomic ions together, so it behaves as a unit because covalent bonds form between the atoms of the polyatomic ions having plus or minus charge hold on it. Just like ammonium ion and NO3 ion. Ammonium, in which NH3 is a neutral or stable configuration by which the formation of nitrogen and hydrogen atoms, 3 covalent bonds are formed and NH3 is a stable compound. But when NH3 attach with 1 hydrogen ion, then ammonium ion NH4 is formed and it is having a positive charge and it is known as polyatomic ion. The another is NO3 in which NO2 is a stable configuration but when it combined with the another oxygen atom, then NO3 negative is formed. So now, thank you so much. Now my discussion of chemical bonding is over. Thank you.